you so much. Cool. Thank you so much for inviting me here today to hang out with you guys and talk to you a bit about brain-computer interfaces and OpenBCI. So let's see, where to start. OpenBCI really came out of a passion project in grad school for me. So I didn't know what BCIs or even EEG or, I actually wasn't even really that interested in neuroscience or biomedical engineering or biosensing until I got to grad school. I did engineering as an undergrad at Columbia, kind of computer graphics and civil engineering. And then I went to Parsons to pursue a Master of Fine Arts in design and technology. And at that point, I was kind of like, I want to switch out of the engineering focused stuff. And I want to focus more on design and creativity and kind of explore this artistic side. But then I stumbled upon, like, a lot of the courses in my program were vocational courses in physical computing, electronics, creative coding, stuff like that. So I was learning these new skills. But then I happened upon this, this tutorial, which I'll show you right now, which is still brilliant. It's one of my favorite, oh, this thing is continue. There we go. So how many, I don't know who can show their hands, but who has encountered this tutorial at some point? No one. Okay, cool. Well, this is a great starting point. If you want to, like, get your hands on a single sensor EEG and kind of see the process of going into Arduino and processing. And actually a lot of this is what this led to OpenBCI. So OpenBCI is kind of a more an extrapolated version of this hack, but this is where I started as a grad student. I found this tutorial online, and it was kind of love at first sight. I had played a lot of contact sports in undergrad, so I played rugby and college football, and I hit my head a couple times. And actually, the last time I got a pretty serious concussion, and it was the first time my junior year of college that I kind of started to think more intensely or deeply about the difference between your brain and your mind, and how, like, you have this hardware, your brain, and you can sustain physical trauma and you can feel it in the software. Like, your mind actually is impacted by this physical trauma. And that was really the first time I started thinking about, like, the kind of the dualism of mind and brain, but only at a high level, kind of philosophical, in a high level philosophical way. And then in grad school, I stumbled upon this tutorial, and it was the first time I was presented with this notion of, like, quantifying my own consciousness. And to me, it was kind of just this, like, love at first sight moment where I just couldn't not do it or learn more. And so over the course of a weekend, I followed this tutorial, started looking at my brain waves dancing in a processing sketch, all open source code and designs. And from that point forward, this was in 2011 or 2012, I just kept working on BCI related projects and low cost EEG systems. So this here was the first project I ever did. This was I think I called it the brain cap, but it was basically that tutorial done by the ITP Frontier nerds, kind of a derivative of it stitched into a baseball cap. And the idea is that I wanted to wear this cap around and collect data to an Android app to track and kind of cross compare activities with moods. So I was going to use EEG as this kind of quantitative glue to track how activities correlated to moods and over the course of the day. So I could label data over time. And it never got fully baked, but I did actually run a couple studies where I was walking around through New York City and recording data to an SD card, and I plotted it in MATLAB and Excel later on, and kind of was like, oh, okay, cool. There's my brain over time. Anyway, I could go into a lot more there, but basically over the course of 2 years, I ended up, for my thesis, building this interactive graphic novel called, actually, maybe I can pull, let's see. I won't launch the app, but basically, this was my thesis, which was Rob 3115, and what it was an interactive graphic novel. You can look it up, but the idea was that as you read this graphic novel, the EEG from your brain is actually influencing the chapters. So it's almost like a subconscious choose your own adventure, and you get to different plot endings based on the way that you cognitively engage with the story. And so that was like a really fun project for me, where I got to exercise my love for illustration and art, but also kind of tap into this new technology that I had discovered, which was with low-cost EEG, and trying to apply it in some kind of interesting, creative way. Anyway, fast forward, I get to the end of grad school. One of my professors, Joel Murphy, who's also my co-founder of OpenBCI, reached out to me and was like, hey, I got a approach to do a subcontract project to build an EEG device for this company, Priori. Do you want to help me out? And I was like, absolutely, 100% want to work with you. So we ended up building a couple prototypes together. The company that he was subcontracted for didn't end up getting phase 2 of the grant. And so we were able to take the prototype to Kickstarter with all the rights and IP, and we launched it as an open source project. And to our great surprise, this was in 2013, we ended up raising $215,000 to essentially build these prototypes, which at the time looked like this in our mind. So they were hexagonal, but that was like the 3D concept render of the board prior to us launching the campaign. And then of course we ended up building the first OpenBCI board, the Cyton, which I will demo for you guys soon. And that was really the beginning of the company, OpenBCI. So, since then, if you want to learn more about this campaign, you can dig in and watch the video and see a bit about the kind of the impetus of the company and why we did it. And I'll tell you more about that in a bit. But now if you fast forward 6 years, here, I'm actually going to minus this so you guys can see. So here's our website, and we now have a lot of different products. So now we don't just support our own hardware, but we actually help bring other open source gadgets and biosensors to market. So this is an example of a product that we helped launch. The individual Josh, who created this product, ran it through crowd supply and got it into the world. And we love open source tools. We love open source biosensors, especially. And so we are helping him get this tool into the world. And as you can see down here, we sell other biosensors as well, the pulse sensor, the myAware muscle sensor. But our real bread and butter products are the OpenBCI tools. So really the PCBs, if you will, printed circuit boards, that do the data acquisition from the body. So the Cyton was the board that we launched in our first campaign, and the Ganglion we launched in our second Kickstarter campaign. And now we have the Ultra Cortex, which I will soon demo for you. Hopefully the battery has enough juice. And yeah, these tools are all kind of like Arduino meets biosensing is essentially, in a nutshell, that's what we're, let's see what we got here. So I'm curious here, show of hands of whoever I can see, who here is familiar with Arduino and has worked with Arduino in the past? A couple people? All right, cool. So Arduino is this amazing toolkit for prototyping and electronics. We essentially started as to try to create the same type of infrastructure or platform for students to get engaged with measuring the brain and looking at the data from the human body. Do we have any questions there before? I might just jump into the live demo because that's the good stuff. That's the fun stuff. Any questions before I carry on? All right, cool. So what I'm going to do now is, hopefully I can get to, all right. Slide this off to the side here for a second. So, all right, let me grab my battery. Live demo. Hopefully it works. All right. Plug in, turn it on. All right, so this here is the Ultra Cortex. So the Ultra Cortex is a 3D printed EEG headset that can measure, if you're using one of the OpenBCI boards or amplifiers, up to 16 channels of electrical data from the scalp. So what I'm doing now is I'm putting the headset on, and this headset is configured with 8 electrodes, which are 1, 2, 3, 4, 5, 6, 7, 8. So they're arrayed around my scalp, and then there are a couple of extra nodes that you can kind of twist into place for comfort. And then these guys here, I will explain what they do in a little bit. but they are the reference and the bias signals of the EEG system. So the inside is like this kind of ocean of electricity. There are neurons discharging electrons all over the place. And these electrons, swell and combine together to create these kind of electrical patterns that end up splashing against your scalp. Who here is familiar with like the way a multimeter works? So if you were, okay, so in electronics, if you took a multimeter, you're basically measuring voltage. You would take like the red end and the black end and put them, for instance, on opposite sides of a battery. And if you measured the voltage of that battery, it would be a steady voltage over time. And that's because the battery is supposed to supply a direct or kind of a steady voltage to a system. Your brain is kind of similar if you were going to measure it with an EEG system. It's basically the same exact tool, except you're measuring much, much, much smaller voltages than a battery. And it's not constant. So the voltage will change over time based on these kind of ebbs and flows and the swells and compressions of electrical data in your brain. And so what I'm going to do here is show you, when I start this system, you'll end up seeing 8 different locations around my scalp where you're actually watching voltage change over time. So it's almost like you're listening to a battery, except the battery is your brain, and the battery has a variable voltage. All right, so without further ado, let's see if I can connect to my system. Moment of truth. Let's just try an auto connect, because it should be that simple. Get close. Oh, that looks good. Christmas lights. So there's a little dongle that's plugged into my computer, and it's got a little blinky LED system. And when it's working, you see a very delightful flicker between red and green LEDs, and it's a good sign. So, all right, cool. We're in. I don't expect all 8 channels to be in good shape at once, but all right. Right now it's auto scaling, so there we go. Sweet. Okay, so what you're looking at here on the left, channels 1, 2, 3, 4, 5, 6, 7, 8. If I show you the plot, so this here is almost like looking top down at my head. And actually, I'm going to switch this from auto to 200 volt. So right now, what I'm doing is I'm setting a fixed range in the y axis of each of these to a maximum of 200 microvolts. So these little signals, these little electrical waves that are splashing out of my brain and onto my skull and against my scalp are oscillating, basically in the 1 to 100 microvolt range. So very, very small values. Here I want to look at just as opposed to plus minus polarity, because you can be kind of plus or minus voltage in terms of reference to your bias. I just want to look at the amplitude. So I'm just going to switch this to a plus. It's kind of like the absolute value, basically. So now you can see that channel 4 is not happy right now. Channel 4 is kind of flatlined. And what that means is this electrode, channel 4, isn't making good contact with my scalp. So what I'm going to try and do is kind of pop it into place and see if I can get a good signal. Oh, it's better. That's good. All right, channel 7 is a little scratchy. It's jumpier than we want it to be. So I'm going to pop channel 7 in a little bit more too. And I know from years of experience where these are located, but it wouldn't take you that long to figure it out if you had your own headset. Cool. All right, so it's not the best it could be, but it's pretty good data, actually. You can see that there isn't too much scratchiness. Now channel 3 is freaking out, so I'm gonna try and pop that in. These 2 electrodes are always the electrodes that give me the most trouble, because that's where I have the most hair. Like I have like shorter hair in the back, and I have kind of a long kind of comb over cut on the top, and so that's where there's the most like hair that these electrodes that have to comb through. All right, so good enough by my standards. I'm gonna try and grind that one in a little more.
So question for you. Which electrodes are you using right now? Like dry, wet, or the comb electrodes? I know that there's a whole bunch on.
Great question. So I brought a couple extras for the demo. The electrodes that are in the headset right now look like this. So they're spiky, and the idea, and they're metal. They're coated in silver chloride, which is a commonly used material for electrodes in dry EEG. The two most commonly used materials are gold and silver chloride. Great question. So now what I'm going to do is I'm going to show you guys some fun stuff. It's okay that channel 3 is cutting in and out. It's just that I got a lot of hair. What I might do is maybe pop this one up. All right, cool. Jiggle it around a little bit. And we're good. Cool. So what I'm going to do now is I'm going to show you some EMG, which is muscle data. So the cool thing, this is really convenient, is that your muscles, your heart, your brain, they all produce the same unit, like physical unit that you can measure, which is voltage. And what you're doing is you're tracking voltage over time. So EMG, which is electromyography for muscle data, it's electricity that comes from the muscles, or voltage that comes from the muscles, is higher in amplitude than brain data. So if I start blinking my eyes, which you'll see are channels 1 and 2 right here, and 1 and 2 right here, you'll see that the most recent data, the stuff that's coming out of my head recently, starts to oscillate with my eye blinks. You see that? So I stopped blinking. That was 1 blink, 2 blinks, 3 blinks, 4 blinks. And so you can see there's this very distinct EMG signal just being generated by channel 1 and 2. So now what I'm going to do is I'm going to show you how I'm a big believer that EMG, electromyography, is going to be the primary tool used for interaction in the future of biosensing. I think that there's a lot of untapped potential for EMG, and I think a lot of people are compelled by the intellectual, just like BCI is kind of, is very exciting, and the idea of controlling something with your mind is really, really enticing, but that doesn't mean we shouldn't use the path of least resistance to solving problems. And a lot of individuals living with motor disabilities still have residual motor function around their body that can be tapped into more elegantly, and the tools just don't exist yet. And so what I want to show you is just how easy it is to create a controller. So these little bar graphs here are normalized between 0 and 1, and they're basically like a rolling average of the amplitude of these channels. So if I grip my jaw, I'm going to produce a ton of EMG all across my scalp, but predominantly like above my ears, because those are where your muscles are. If you actually if you grit your jaw and you feel the muscles above your ear, you can feel those muscles clenching. So now I'm going to do it and watch specifically channels 3, 4, 5, 6. You see how there's this like really high frequency, scratchy data. So that's just me flexing muscles above my ear and in my head. And it's really, really easy to do that. Super reliable. Like as long as the sensor is attached, you're going to get the data. And because the data is 10 to 100 times more higher in amplitude than EEG, it's that much easier to detect. So now, but now though, we wouldn't be calling this a BCI if we couldn't listen to the brain, right? That's it's still the exciting part. So now what I want to do is demo to you an alpha frequency, which I can produce from my visual cortex just by closing my eyes. And so one thing that's super cool about this, and I love to use this as a demo, is because it actually gives you a lot of insight and kind of intuition into how the brain works. So your visual cortex is super powerful. It takes up a lot of your brain, pretty much the entire back of your head, and it's responsible for processing everything that you see, everything that all of your visual information. And so when your eyes are open, it's almost like your visual cortex kind of looks like noise, because you have all these little neurons and little networks that are doing different things and responsible for colors and patterns and shapes and memories of shapes and colors and whatnot. And so it just kind of looks like chaos. But then when you close your eyes and you kind of like shut down your visual cortex, or you at least shut down the stimuli that's going to your visual cortex, it returns to an alpha frequency. It's almost like a heartbeat that it isn't like, but it's your brain. It's this dependable alpha frequency that returns when there's there's a lack of stimuli, essentially. And so what I want you to do is, you got to tell me when. I'm going to close my eyes, and what I want you to do is look. Here we go, actually. So let me go to band power. So what I want you to do, and actually I'll make this one the head plot. You should see this kind of start to light up a little bit and become more opaque than the rest of my head. But most notably, you'll see the alpha bar here, which is it's a frequency band representing waves between, I think it's 10 and 15 hertz, or maybe 8 and 13. No, 10 and 15 sounds about right. So you'll see that bar grow. And actually what I'm going to do, I'm showing off the flexibility of the GUI right now. By the way, this is all open source code. If you want to see how this GUI is built, you can look at all the code. You know, not all of it's pretty, but it does work. So here we have, okay, FFT. So this is, who here is familiar with FFT, or fast Fourier transform, as a signal processing tool? Cool, that's great. So this right here is an FFT representation, fast Fourier transform, of the time series data off to the left. And so you can actually see that each of these colored lines it corresponds to the same color in the time series. Okay? And so when I close my eyes, you're going to see these wobbles appear. And there should be about 11 wobbles per second. So this is present time. This is 1 second ago, 2 seconds ago, 3 seconds ago, 4 or 5. So you'll see these little wobbles coming out of my head, and predominantly in channels 7 and 8 at the back of my head. And you'll also see a little spike above 10 or 11 hertz, which is the frequency representation of the data. So you need to tell me when I start doing it, because I can't tell because my eyes are closed. All right? And the pressure is on. Here we go.
I think we see it.
All right, cool. So I paused the data, and yep, you definitely see it. So see this spike right here? That's an alpha frequency at about 10 hertz. And what I'm going to try to do is, hopefully this updates. Oh yeah, cool. So here I expanded or kind of lowered my y-axis maximum. And you can see, you can count these little waves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so those 10 waves correlate to this hump, this kind of camel hump you see in the FFT, which is above 10 hertz. And so that is a brainwave. Pretty cool, huh? Actually, I'm going to bring this down because I think it's fun to see everyone's reactions in the little, here. Is that all right? Oh, and you popped off to the side. Cool. Here's what I'll do.
In this picture, I just
Sorry,
asked
say again?
about the picture.
Say again?
In the graph of like amplitude and frequency, so all that like other stuff that's not the spike, like what part is that? Like, is that part just not being shown on the graph on the left?
So if I understand your question, it's basically all this other scratchy stuff here.
Yeah.
So that actually, those frequencies do exist amongst these waves, but they exist at lower amplitudes. So the fact that alpha was coming in and was kind of taking over, and that's why you can see it in the raw data stream, because as it becomes more pronounced, all these other frequencies are just kind of riding that wave. So as an example, this is kind of like a little bit of wave addition and wave subtraction math. So you know how, like, if you have a wave like this, and then you've got another one that's like, if you add them together, it'll be like, and you'll see the higher frequency wave riding the lower frequency wave. And so that's in a nutshell, that's wave addition. So what we're doing with EEG is we're looking at all of the potential waves that it could exist that are being emitted from the brain combined, and we're trying to reverse engineer, we're trying to extract the power bands, which are represented here. And so like delta is everything that's 0 to 4 hertz. So anything between 0 waves per second and 4 waves per second. Does that make sense, or am I losing you?
Yeah, no, that totally made sense. So it's kind of like you're looking for, that was like a really good explanation.
Okay, cool.
Looking for like the frequencies like within the larger waves.
Exactly. Okay. And so EEG is like, okay, I love this example. And my friend Yannick, who's like one of the co-founders of Neurotech X, I don't know if you know him, but he always makes fun of me because he makes fun of me for using the same analogy for like the last 6 years. But it's such a good one. EEG is like your like the brain is this huge ocean, right? And there are like wind patterns and earthquakes and all sorts of things going on out in the ocean that are influencing the waves that eventually end up crashing on the beach. And with EEG, it's like we're standing on the beach and we're watching the waves come in, and we're trying to infer what's going on out in the ocean. It's like, okay, cool. Well, there was a giant tidal wave, that hit like at that point in time. So something weird must have happened out there. And like in a sense, that's like the level of fidelity we have with EEG. We're trying to figure out what's going on way out in the ocean by measuring what's happening on the shore of the beach. We can do things that are a little bit more sophisticated now, like source localization. And what source localization is you can listen from multiple beaches, and you can look for the same patterns emerging at those different beaches, and then try to infer through kind of three-dimensional triangulation where certain frequencies are propagating from within inside the head, if that makes sense. And so, that's like, with one channel of EEG data, you could never do that because you only have one dimension that the data is flowing in. But as you start to add more electrodes, you can start to do kind of a spatial analysis of what's going on deeper. Granted, there's a lot of noise still. You have like the skull, the skin, muscles, hair, all this other stuff that can distort data, but we won't go into that right now. Cool. So any other questions right now?
Yeah, I'm looking at the bottom icons of your computer because I'm nosy. And one of them seems to be, do you use OSC, the data monitor?
Let's see, which one are we talking about here?
That one right there, the black one.
This one?
Yeah.
This one is actually the GUI that I'm running
like
now.
Processing or something?
Yeah, so the OpenBCI GUI is a processing sketch.
Oh, okay.
It is probably, we took it so far. I mean, processing is amazing. I love, working with processing. If you're going to build a huge application, there might be more efficient ways to do so. But we started with processing, and we just ended up building out this whole interface. And amazingly, it worked. We stuck with it, and so that's part of the reason why you can see how everything was built. You can see how all of the data processing, signal processing, UX and the responsiveness of the UX. You can look into all of that from our GitHub.
And how are you streaming the data to
Great
your app?
question. So on the headset, there is an Arduino, which is essentially a Bluetooth radio module. The part is actually end of life, but we have a bunch of them, which is good. But that is paired with a little dongle that you plug into a USB port on your computer, and they're paired on the same channel. And so we're doing kind of transceiver to transceiver communication between those.
So this isn't over a network or anything like that?
Nope, just Bluetooth.
Okay.
And we have actually, we have what the Wi-Fi shield, which if you want to use higher data rates, you can buy the Wi-Fi shield, which kind of upgrades your system, and then you can stream it higher higher sample rates.
Okay.
And then the ganglion is our low-cost system. This runs for $200 just for the board itself. And it can hold up to 4 channels, or it can take in up to 4 channels of EEG, EMG, ECG. So ECG being heart, electrocardiogram. And yeah, cool.
I have a question about the electrodes.
Sure.
Are you using dry or wet electrodes? I think I missed in the earlier.
Currently, we are using, right now I'm using dry electrodes.
Okay.
So I'm using this little guy here.
Okay, gotcha. What type of metal was that one?
That one is silver chloride.
Okay.
All right.
What's the impedance kind of that you would have to achieve for you to get a good or a decent signal? Because I know everyone here is probably from like different parts of CruX or maybe not in CruX, but we did have the ganglion board about like 2 years ago. We first got it, but it hasn't been used recently. And I know a reason that it hasn't been used recently is because we had the snap dry electrodes that just weren't they weren't getting a good signal to noise ratio. So yeah, I was just wondering more about what can we do to improve that quality?
Great question. So the ganglion certainly has worse signal to noise ratio than the Cyton. Like the Cyton is just a more expensive system, and it has a more sophisticated ADC, as well as the chip that it uses, the ADS-1299, which is a Texas Instruments chip, has built-in impedance checks. So I could actually, right now, if I wanted to check the impedance on channel 1, hopefully this works. I can run this in. And right now, here we go. So we're looking at 48 kiloohms, which is, if you have a wet gold cup electrode, like you use paste and you stick it through your hair or on your scalp, you'll probably get an impedance that's 1/10 this. So below 5 kiloohms. And actually, so as a cross comparison, let's turn on channel 2 and see what channel 2 is, which is comparable, suspiciously close. And yeah, so that's how you do the impedance check. And yeah, just if you have questions, just let them fly. Otherwise, I'm going to keep kind of demoing stuff. So sounds good.
Question.
So yep. Okay, cool. Just
I think we have one question.
Sure.
About your customer base. Like who's buying these and like what are they using them for?
Great question. So we, as an open source company, are really admired and used widely by education. So like people, like students, teachers, and scientists love data, like real raw data tools for doing things. And we pride ourselves in being a scientific tool first and foremost. So that's part of our ethos and why, as a distributor and seller of tools, we don't charge for data, because I think, at the end of the day, we're trying to push science forward. We're trying to make it easier and cheaper for people to do neuroscience. And so, yeah, so anyway, sorry, can you repeat your question again? The main customer bases, right? It's basically education, research. We're very proud of the growing list of citations. So like when we launched OpenBCI in 2013, at that time, like before scientists will really start using the tool, they want it to be validated. So in the first couple of years, the majority of our customer base was people who were kind of like new tech adopters, DIY scientists who just were like, all right, I'll take a chance on this new tool. And then in 2014, 2015, a couple papers came out that baselined OpenBCI hardware against much more expensive kind of research grade equipment from various other companies. And the results were really great. Like we stacked up right against systems that cost 10 to 20 times more than ours. And since then, the amount of citations and publications that are coming out of grad students, PhD students, postdocs, and researchers that are just publishing with OpenBCI has gone way up. And that's like, for me, that, it makes me feel like what we've done is worth it, is that we've been able to push science forward and push neuroscience forward in this way. And so, yeah, that's one thing I'm very proud of with regards to OpenBCI. Yeah. So hopefully that answers your question.
Yeah. It was interesting to hear about the journey of your company a little bit.
Yep. And I would say the other, we've sold hardware to, I think, 84 different countries now. And while a lot of that has been for education and research, there are actually a lot of companies that end up starting as a result of prototyping hardware and applications on the OpenBCI platform. So there are actually a number of startups who I've met at like CES or various conferences where I'll come up and I'll introduce myself. I'm like, oh, hey, I co-founded OpenBCI. Love what you're doing. And they'll say, oh, we used OpenBCI to prototype our first systems. Like, thanks so much for, exposing all of the guts and the firmware and the hardware designs. So that too really means a lot to me, to be able to kind of like propagate the industry, if you will, or kind of proliferate the technology. So yeah, we also supply hardware and software to startups and enterprise partners as well.
Do you know of any work being done with active electrodes to try to get a even better signal to noise ratio?
So it's funny you should mention that. We have been working on an active electrode, which is currently in the kind of R&D phases, if you will. And what I'll do is I'll show, we did a dynamic simulation of the electrode. So it's a conductive polymer. It's a rubber that's infused with some conductive material or sediment that can, have the flexible properties of rubber, but still conduct electricity. And so, yeah, we're doing a lot of work right now and exploring a number of options and partnerships around much better electrodes. And this is actually, we haven't shown many people this, so this is like, this is pretty cool. You guys are getting exclusive access to this right now. So,
that's good. Is there any estimated date for that?
We'll probably start like talking about it more come fall of this year. We're working on a really cool project that I can't talk too much about, but I can say that we're doing an AR and VR integration. So basically making a tool that merges the mixed reality, virtual reality developer ecosystem with the biosensing, neurotech, kind of measure data from the body platform that OpenBCI already has. And we're really excited. We have a very cool partnership that's developing, and yeah, it's going to be fun when we start to publish more about it. So, and similarly, that we haven't talked much about that either. So you guys are getting kind of a exclusive here. For a little sneak preview, these are some of the concepts from one HMD manufacturer that were. It's basically a sensor harness and face pad that are integrated into a VR headset. And the idea is that it's actually headset agnostic. So if you have different types of VR headsets, you can strap this thing on and measure a very, very rich network of physiological data from the face and scalp while simulating super immersive experiences in VR or interacting with digital content in AR. And so this is pretty cool here. I don't know if you guys have ever tried out HoloLens, but here we have Microsoft HoloLens AR. Just hanging out on my desk. That's actually my girlfriend. She works for a cool company called Spatial, and they do a really amazing kind of Zoom in 3D, effectively. It's like a kind of a teleconferencing system where you can wear an AR headset and kind of grab things and stretch them out. So definitely check them out, but I'll leave it at that for now. The company's called Spatial.
Thank you.
Yeah. So that's some of the stuff that we're working on is active electrodes, integrations with AR, VR, but then also helping other companies in the space get off the ground. So here, like for instance, in the fall, we helped, actually the product is not in the store right now because it's sold out, but there's a company called Idun. They're a Swiss company and they make electrodes. And here is an experimental or kind of a early version of, they call it the avocado, as you can see, because it looks like an avocado. But basically, it is a jelly electrode that's dry, but has impedances, and you can slap it on, and you can reuse it and kind of clean it off. But you don't have to apply a gel, and it has impedances that are much closer to a wet electrode. So you can put them on the scalp. And so, we're always looking to help support other companies that are, supplying new technologies to the space and get them into our store and kind of help the go-to-market process. So if you guys have any cool ideas or projects, now or in the future that are related to biosensing and you want to help, you need help commercializing or go-to-market, definitely reach out to me. Yeah. Cool. Let me see. My computer might run out of juice, and that would be tragic. Let me find the my charger. Oh, no, it's not plugged in. I suspect my girlfriend stole it. Cool. So, let's see. You guys have any questions? It could be technical or it can be high level, like, philosophical, ethical. Yeah, you let me know.
What do you think about Neuralink? Have you heard about Neuralink, Elon Musk company?
Yeah, of course. Neuralink is cool. It's very, it's exciting. Like when that whole thing happened and Elon Musk all of a sudden started caring about brain-computer interfaces, it definitely was a really good thing for the industry. It brought a lot of attention and a lot of interest to a space that, has typically been seen as a field of science up until the last 2 years, and now it's actually seen as an industry and one that has a huge commercial potential for startups and companies. Neuralink is, as far as I know, exploring an invasive route where they're going to be doing surgeries and opening up the scalp and trying to get directly to the source. For me, personally, I'm way more interested in non-invasive solutions. And I think it's because we've barely cracked the surface of what we can do with non-invasive technology. And I think that in the next 10 years, we can make a lot of progress building truly life-changing and world-changing applications and technologies with non-invasive biosensing and neurosensors. Yeah, that's, I just think that in the near term, we can make a much bigger impact if we focus on non-invasive technology. And then other people disagree with me and people whose opinions I respect greatly. But I'm putting my money on non-invasive. I think there's a lot we can do, especially with the advent of wearable computers and especially putting like high-powered computers on your head. We now have, it's now not strange to be wearing like a display and a processor on your head and on your body and having all of this incredible sensing and processing capability on your body. And I think as a result, we're going to see huge strides in the application space in both in terms of health, but also entertainment, kind of routine optimization and productivity. I think these areas are gonna see a huge surge of biosensing applications in the coming 5 to 10 years, most of which will be non-invasive. Yeah.
I just had like a follow-up on that, since
Sure.
you that you might be willing to talk about like ethics and stuff in terms of Neuralink and like these ideas of like enhanced intelligence. Some of that like seems kind of maybe unethical in terms of what Elon Musk is proposing might happen in the future, with like combining our intelligence with artificial intelligence and with all of the information that's like on the internet. What is sort of your ideas on like that ethical aspect?
I love this question. And I'm so glad that you brought it up, because I have another image that I want to share with you, which is, oh, hang on, I stopped my data. There we go. Let's see if I can get this image open. All right, cool. So I thought a lot about this. I've been thinking a lot about this for the last 5 years, but it's this idea that we're progressing in the kind of the evolution of humanity alongside technology. We're progressing to this future where there's a more seamless integration between you and your computer. Hey, Bree. Cool. Sorry, my girlfriend's trying to cook dinner. So if you hear some clanking in the background, just bear with me. So we're progressing towards this future where there's this more kind of seamless, nuanced integration between you and technology. And that is both very, very exciting, but also very scary, because it means that, systems can be kind of influencing us and altering our perception of reality or the stimuli that is presented to us, potentially without us knowing about it. And so what you see here in this diagram is what I like to call the kind of like closed loop. It's this idea of closed loop computing, where you as a human, or as your mind, you have this kind of like subconscious input to an AI agent that's operating in the background of your technology. Where we are right now is very much in this kind of central region, where we consciously interact with our machines, and we have conscious feedback where we see emails, we see notifications, we get, kind of like information that we perceive asynchronously, and then we operate and we do other things. But I think where we're heading as a species is a much more kind of background closed loop system, where you have subconscious input and then also subconscious feedback from a machine. So take a minute to just think about that. And so I don't know about you, but when I think about this future, and I think about all the ways that my perception of reality can be altered, whether it's through advertisements or changes in audio, light, the frequency or the frame rate of your screen that you're looking at. Like, you could potentially toggle between like a frame rate of 60 and 90, and it might have a subtle shift on your level of mental fatigue or your focus or things like that. And this could happen to you without you knowing. You could potentially like tell your little robot friend, hey, today I want to be creative between the hours of 2 and 4 p.m. and I want to be highly productive before noon so that I can get all my emails out of the way. Can you optimize my brain for me? And your little AI friend might be like, no problem. I've seen what your brain looks like during these states in the past. So what I'm going to do is just kind of start tweaking little knobs that I have access to in real time until I start seeing the patterns that I want to see. I don't think that this is far-fetched. I think that if you collected enough data, enough labeled data about yourself in the context of your environment and the applications you're interacting with and the things that you're touching and whatever, that a highly personalized kind of meta representation of your consciousness could exist. And it could be used as a kind of like underlying data set to then toggle these little knobs and the kind of subconscious feedback, the bottom of the circle, that goes back to you to alter and optimize your routine and your mental state. And so when I think about this future and what it means for not just my mind, but kind of collective human consciousness, and how vulnerable, truly vulnerable collective human consciousness is at this point in time, if we don't do it right, that's really what drives me as an entrepreneur and as a creator, is trying to kind of stake out these future scenarios where we do it the right way. Like, I think the best way to avoid these kind of dystopian futures that we don't want to live is to build an alternative now and pull people in that direction. And I think that's one of the coolest things about entrepreneurship and just kind of really just creating in general. You have this ability to define the future. You know, if you do it first and you show the world the right way to do it, then you potentially, not potentially, you have an impact on the future of humanity. And so, to get back to your question about ethics and kind of this future where we have AI and the human minds living harmoniously or not, I think it is going to happen. I think we are already trending in this direction. Great examples of this kind of subconscious feedback are you think about like your Instagram search feed or any social media that you're on, where you're allowing metadata on you across the internet to optimize the content that's being shown to you, which is pretty much the default setting of any application that you sign up for. You're already getting content that's curated based on the way that you're interacting with prior content. And it's just, right now, it's at a very low fidelity. And the forces at play, both corporate, personal, medical, whatever, the forces at play, are, they have different priorities, right? In terms of the way that your brain gets optimized. And, like the future that I want to see is where you as an individual have ultimate high level control over the way that this little system, little Jiminy Cricket, if you will, your kind of digital Jiminy Cricket, the way that that system is like optimizing your reality or the high level parameters for that function, you should be the one putting in those values. And you should understand how the equation works beneath that. Anyway, this is obviously, in an ideal world, this is how it would be, but I don't think that it's guaranteed. And I think that it's really important that we, as designers, creators, scientists, innovators, that we make sure we start thinking about, these potential bad scenarios of the way that the human mind gets altered, and design the alternative now.
What do you think about like connecting brains instead of connecting like a brain to a computer, but connecting individual brains together? Like basically like social connections to a different level, I guess.
Great question. Let's see if I can find, there's this thing from the University of Washington called BrainNet. And I'm going to pull it up because I'm very proud that they used OpenBCI. So how you and your friends can play a video game together using only your minds. Wow. So as you can see here, I would look into this at a later time because it's pretty in depth, but you can see there's a familiar looking octagon right there. Yeah, I don't know if you noticed the shape of our board, but they used EEG equipment to basically have two individuals in separate locations issue commands to a third individual that had to then relay commands back. I hope I'm not butchering this, but relay commands back to a game to control the game. So there were two players that were watching a game, and they could see, and so they would issue the commands, and then the third player would receive those, and then yes, the third player was the controller of the actual game. So they had to kind of pass messages through this blind third person to interact with the game. It's very cool. I would look into it in more detail, but yeah, I think that this is possible. Though I think the demo at this point, the demos are kind of low fidelity at this point, but I think we'll continue to grow and improve them. Hang on one sec. I'm going to grab a charger before my computer dies. All right. Any other questions while we here. I really enjoyed that question about the ethics, because I think it's, I try to talk about that for a little bit in every conversation or talk or presentation that I give, because I think it's extremely important. We've seen some some unfortunate things happen in the last decade surrounding data privacy, and and just how the attention of people and populations of people is being monetized, and there's kind of a new economy around people's attention, and I think that has the potential to get worse with tools and systems like brain-computer interfaces. So it's really important that we keep that in consideration as we use the tools and as we build the industry, essentially.
Yeah, I think it's really interesting because, to be honest, like I never thought about the ethics from that perspective, from like optimization of our brains and like for things like advertising. I was always thinking about it in terms of like the ideas of making like gaining knowledge obsolete, in terms of the fact that like we wouldn't need to learn anymore because everything could just be given to us, sort of like how a computer just has all this knowledge in terms of like language learning, stuff like that. So I'm wondering like if you think that is a possibility in the future, because that's sort of like what worries me most, I think, or if you think that's something like so far out. And
I think so. It's a good question. Like, have you guys seen the Matrix, the original Matrix? How they kind of plug in, download, like, I know Kung Fu. I don't think we're going to be there anytime soon, but I do think that we will start to understand like when the brain is in a state for optimal learning, and potentially guide the brain to that state, and make the process of learning more efficient. I think that's going to be like the first step, and then maybe like a year or two later we'll be able to jack in and just download a language or whatever. But I I guess to answer your question, I think that it's theoretically possible to like optimize the mind for faster data acquisition and knowledge acquisition. What that means for like people and populations across the world is, it's another ethical consideration, which is the potential impacts of brain-computer interfacing and advanced neurotech on social stratification. So if a tool like this is possible and ends up getting built and costs $20,000, and anyone with $20,000 can buy this tool and learn 4 times more effectively, it creates this very unfortunate divide between people who can buy things for $20,000 and people who can't, right? And so, that's another scenario that we have to be mindful of, is the democratization of the tools. And that's actually has a lot to do with why, with the mission and the impetus of OpenBCI as a company. We really set out to try and lower the barrier of entry, and to bring really kind of ignite the industry and make it commoditize BCIs in a way. Like how do we make these tools not black box, not only owned and produced by like the wealthy in ivory towers, but how do we actually bring them out of the laboratory, bring them into the real world, and also make them cost effective for anybody. And so, yeah, that really is a core part of OpenBCI's values as a company. Cool.
All right, so it's been, I don't want to interrupt anyone, but I just wanted to see like if anyone has class that they need to attend, that they're feel free to like drop the call. And also I wanted to check in with Connor to see how much time he had before we keep going.
I mean, I'm down to hang out as long as you guys want to hang out, but it's if you guys have more questions, I'm happy to share more. Let's see, I could, let's see. If you want to learn more about OpenBCI, we have tons of stuff on the internet, and our website is nice, I think. And the community page, we actually just switched servers for our website. So if there's a couple, there might be little bugs. There's supposed to be a little spinny wheel here, which isn't showing up, but it's okay. We'll knock that action item off the list. But you can see posts and other things that people have done with OpenBCI. I also highly recommend that you sign up for our newsletter, which you can do join mailing list here, because we send out a newsletter like one a month, sometimes two, sorry, but like usually always one a month. And we'll talk about like events we're going to be at, new products that we're launching, products that other people are launching that we're helping get out into the world, cool projects that people have done with OpenBCI. So, we keep it kind of like community focused, cool tools. If we add something new to the GUI or a new feature, we'll include that in the newsletter. But it's fun. It's an active community, and the people on the forum, for instance, are very, very communicative. This here is William Croft. He's a BCI angel of the internet. He just somehow knows everything about neuroscience, brain-computer interfacing. You'll find him on obscure forums where you think, no one's going to be responding to your question. He'll find you there and he'll respond to your question. It's pretty unbelievable. But we're very fortunate to have him as like the keeper of the forum. Most likely, if you ask a question, he's going to be the one responding. So if you're very familiar with our hardware, you'll surely be familiar with Will Croft. But it's like OpenBCI is beautiful in that way because we have people who really just believe in what we're trying to do and are willing to put time into the project to just kind of propagate the technology and get more BCIs into the hands of students and creators.
What do you recommend for someone who wants to work in this field in the future? Like, do you need to go to grad school, and so on?
It's a great question. I went to grad school. That doesn't mean it's the only way to start doing this type of thing. I think that the internet is amazing, and most of the stuff that I learned about building BCI was actually from the internet. I think that grad school is a great way of cultivating a community and a network of people that you can work with in the future. A lot of my, for instance, my co-founder was a professor of mine in grad school. So grad school is a way, I think it's better for networking and developing relationships than anything. And also maybe just having the right conversation at the right time to spark some piece of knowledge or intrigue that you wouldn't have otherwise stumbled upon. I think that, real life interactions, it's hard to come across that on the internet sometimes. And I think that's one of the other benefits of grad school. But that being said, grad school is super expensive. I'm still paying off student loans from grad school. And I finished in 2013. So, it's like, there's an opportunity cost either way. But that said, I loved grad school. I wouldn't change what my past for sure. Let's see.
Cool. I have a question. Going back to brain optimization, I was wondering what your thoughts are on the efficacy of neurofeedback and how that's being used as a tool for, increasing focus and getting rid of anxiety and depression, and I guess where you see it in the future.
Sorry, repeat your question. Basically, neurofeedback.
Yeah,
combating.
How you think it's just how neurofeedback works as a tool, and how, if you think there's a future, because I work at a neurofeedback clinic, so I'm just wondering what your thoughts are on where neurofeedback is in the future, how well you think it might work.
Sure. I think neurofeedback definitely works. It's a real thing. For instance, one feature I've wanted to implement in the GUI for a long time is, how when I did the eyes closed thing, I needed you guys to tell me. Well, I want a little knob in there that I can click and it'll give me audio feedback that's, basically volume correlated to the amplitude of my alpha, or the power of my alpha. Super easy addition. If I had that, I would know that when my alpha is increasing. So that's an example of neurofeedback that I don't know why we haven't implemented it yet. Anyway, neurofeedback is super real. And one time this like neurofeedback guru, like a wizard, came into our headquarters, and like I had looked at a lot of my own EEG just using OpenBCI equipment. You know, and here's this guy who's been running a practice, like a clinical practice of teaching people how to do very sophisticated, like to turn on very sophisticated cocktails of frequencies around their head. And the way you do it is like, you know, there are kind of these known data sets associated with basically alpha correlations between hemispheres and certain frequencies in certain locations of the brain. And if you know what you want those frequencies to be, you can set the system up in a state where it's listening for those regions of the brain to reach certain amplitudes of certain frequencies. And if you start attaining this, you know, you can get some kind of audio or visual neurofeedback as an indicator you're doing this. You're thinking correctly, if you will. And so this guy had trained in this for like, you know, maybe 20 years or something, and had been working with all different types of EEG, and had trained his brain to be able to like turn on and off frequencies in different parts of his head. And I put the ultra cortex on him. He had never worn it before, but, you know, like set it up, and I was like, all right, can you just like turn on alpha? I'd always tried to turn on alpha with my eyes open, and one time I've like kind of done it for like a second or two, and then I got super excited, and I think my excitement just kind of just threw everything off. But within a second, I put the headset on this guy, and I was like, hey, can you just like turn on alpha? And he was like, hang on, let me see, it's been a while. And he just, his face kind of glazed over, and his eyes were still open. But then all of a sudden, every single channel on like every single time series channel here just went like, and he just like basically like turned on this frequency on command with his eyes open, like, you know. So that was like a this is super real moment for me.
Yeah,
I saw him do that, and I was like, okay, like this is, people can clearly train in this, and if you wanted to, you could like become a neuro wizard and turn on and off frequencies, but it just takes training. It takes like, and you need the feedback. So yeah.
The guy's name, just curious if you can.
I forget the guy. I can look it up and I can share it with you. But you know, take my email down and shoot me an email. My email is just Connor. Actually, let's see if I have some cards here. Oh, here we go. I'll cover up my phone number. I need to get rid of this on my card. Too many robots call me.
You can also send it out. I think we have it with the CruX email, so we can definitely send that out to our members and anyone who's interested.
Yeah, it's just Connor at openbci.com. One N in my first name. I don't know if you guys get as many phone calls from robots as I do, but it's probably because I made the mistake of putting my phone number on my business card 6 years ago. And I've had the same business card ever since. So don't make that mistake. Cool. Any other questions?
I had two more questions. The first one is about, so before you were talking about like, I think Fourier transformations and like extracting the frequencies that we want. And I'm wondering like if in the industry right now, people are still developing these algorithms, or it's more like people are using these set algorithms that have already been made and to try to like do cool things with the data that they gather from the algorithms.
I think we're really at the beginning. It's of actually building meaningful algorithms for interpreting the data. I think where we're at in the industry is like we now have access to all these tools. We now have access to, you know, we are in a state where the hardware is kind of becoming commoditized, and access to the data is way, way, way easier and cheaper than it used to be. And now we're in a place where like everyone's learning how to do machine learning. Everyone's learning how to do data science. And that's great. And now I think that there's a huge opportunity in the industry now for companies to emerge that are making sense of the data, like trying to build both generic machine learning algorithms that can be mapped to a population of people, but also highly personalized algorithms that can take your data over time and manipulate, or like, you know, in my mind, I think the best like commercial solutions and applications are going to be ones that start with classifiers that are based on a population. So you'll get a tool, you'll get a device, and you'll be, in the beginning, your reaction or response to certain classifiers and algorithms will be based on your real-time comparison to the population of all people tested, or to produce the classifier. And over time, that classifier will be adapted to more highly prioritized data that you're collecting and generating yourself. So in the beginning, it's gonna be like, imagine if you had a shoe that like you bought from wherever, Amazon, you put it on, and in the beginning it like kind of fits your foot. It's like, oh, okay, cool, size 10, great. And then over time, it's just slowly adapted and like melded and shrunk or expanded to the shape and size of your foot. I think that's the way like the future of BCI applications are going to be. It's going to be, you know, some generic classifier where your initial engagement is based on your comparison to the aggregate, and then that slowly transitions into being highly personalized. And that I think will be fundamental to, you know, to applications that use biometric data in the future. Yeah.
Cool, thanks. And then my second question, I don't know if you can answer this, but I think like for lots of us undergrads, if we're interested in neurotechnology, it's sort of hard for us to figure out what area to focus on when there's like so many different majors, and it's like you have to choose a major, basically like neuroscience or computer science or electrical engineering. Is there like a sort of basis, like knowledge base, or like one subject that you think is like the basis for neurotechnology that would be like good to focus on, that would then lead to like us having an understanding of the other subjects? I don't know, that might be a difficult question.
No, I think it's a really good question. And I think the short answer is you can be involved in the space coming from many different backgrounds. So for instance, at OpenBCI, the 3 core team members are me, Shirley, and Joe. Joe did political science. He's our director of business development and marketing. Super instrumental to the company. You know, he doesn't have a scientific background, but you know, he brings tons of industry experience, having worked at companies like AppNexus and Salesforce, to us being able to like actually sell these things, right? And then Shirley comes from a biomedical engineering background, but she's actually working on the operations side of the company. And then I come from like a civil engineering background, and I did a lot of computer graphics. And then I went to a design program and kind of ended up coming into the BCI industry from like really the kind of split between design and engineering, but without being an expert at either. And so, but to like, you know, to give you a more tangible answer, I think that computer science and electrical engineering are foundational principles to, you know, really the future of technology, but also like if you're interested in interfacing the body and biosensing and neurosensors and things like that, you need to have some, at least proficiency in electronics and, you know, the translation of electrical signals at a low level. But that's also very helpful for understanding computers as well. So, you know, like if you can do some kind of split between, you know, kind of the more theoretical side, like a neuroscience or a computational neuroscience, where you're getting, you know, math, data science, signal processing, and also, you know, neuroscience. You know, a lot of programs will do split between neuroscience and computer science. I'm not sure if you guys have the ability to do dual degrees or anything like that, but Yeah, you can't go wrong with computer science or any type of engineering, really. But like I said, there are so many ways to help out and to contribute to the industry now. I don't think it's limited to a specific field of study.
Thanks.
Yeah. Any other questions? Cool.
Yeah, if anyone has any additional questions, feel free to I mean, you can reach out to us at the cruxucla@gmail.com email, and we can forward them to Connor or OpenBCI in general. You can contact him directly if you're comfortable with that, sharing. You've shared your email with us already. But yeah, thank you so much for joining us. If you have any last comments you want to make.
I just want to say thank you. This has been a pleasure. I used to teach, and this is fun. It's giving me flashbacks of teaching, and it's making me want to do it again. I think it's really awesome that you guys are volunteering to participate in something like this outside of your probably already hectic or chaotic remote school situation. I think going out of your way to participate in meetups and I think that some of the best things I did for getting to where I am with OpenBCI and starting my own company was the stuff you do at nighttime and the stuff you do with your free time. Creating, really. I think that I don't know, not everyone feels this way, but I think creating something, whether it's an application, a device, a tool, something, writing, a piece of writing, I think is really, really valuable, and it's a way to try and make your mark on the future. So I just encourage you guys to learn, but also build things, create things, because I think it'll go a long way for positively changing the world. Cool.
Awesome.
Thank you.
Well, thank you so much, everyone, for coming. Thank you, Connor, it was so much fun, and it was really awesome to hear you talk.
Yeah, you guys had great questions. It was truly a pleasure, and let me know if you ever want part 2.
Yeah.
We definitely will. All right, I'm gonna end the call. Bye, everyone. Thank you for coming.
Bye.
Yeah. Thanks, Connor.
Bye.
Bye, everybody. Thank you guys so much.